Hey, everybody. Thanks again for taking some time to come see another session of DynamoDB Office Hours. My name is Rick Houlihan. As you know, I work on the DynamoDB service team. This week, we're going to do another data modeling session. I think I announced on Twitter it's going to be about a phone billing service. I had a couple suggestions on Twitter. A couple things came in as far as access patterns that people want to see. And so, we'll kind of cut to the chase in a minute here. As always, this is an ad hoc session, so feel free to join and mention what you'd like to see. If you have any patterns as we kind of go through things, if you have any questions, whatnot. I'm not sure if you have any moderators online, but I'm watching the chat channel or chat stream, so hopefully I'll catch anything that you might be interested in knowing a little bit more about. If not, I'll review at some point. And I'm assuming that the audio is good. We're all working and everybody's seeing everything. So that's always a good thing. And let's just go ahead and hop right to it. Okay, so let me see. So this is the data structures that we're going to be working with today. Again, this is just kind of online from databaseanswers.org. They've got its library of schemas out there. Mr. Barry Williams, who I've never met, who at some point we'd probably like to meet because I use a lot of his schemas and break these down and kind of transform them into NoSQL data structures, but using the same kind of entity structures that he's kind of defined here. But anyways, it's kind of almost like there's two categories of data. We've got some customer data there's tracking of addresses here to customers and pinning those that historical data around addresses, and then there's obviously customer phone numbers and the records around phone numbers. And it's kind of interesting. He calls out that there's some calculations done between customer phone calls and bill detail lines and whatnot. So this actually makes for a pretty good point where we can talk to Lambda interactions, right? As items hit the table, maybe those bill detail lines get filled in by some secondary process, right? Which sounds like that's kind of what's happening down there anyway. So, but first off, we'll start off with the kind of customer sections here and look at how we're going to, create this top level, record hierarchy. So again, a couple different things we're looking at. I'm just going to throw this off to the side here so I can reference that while I'm modeling for you. And hopefully you can see, you can see the table. So again, customer data is going to be more customer centric. So we're probably going to want to create a couple entity objects here. And I'm thinking we'll create just a series of address items inside of a customer partition here to solve most of our issues around the customer address history, right? So that's pretty straightforward. Let's create that customer record. And this is basically his metadata. Yeah, that's customer. And we'll tack on a couple attributes there. He's got a name, email, address. So let's just go ahead and add those attributes. Name. I don't know if we're going to, address, that's interesting because there's an address here, but I guess that you could say that might be customer's primary address. It's almost like maybe it's denormalized, right? We've got, some historical range of addresses, or maybe we have customers that are associated by address ID. Yeah, that must be what that's supposed to be, is like an address ID. Give me all the customers with the same address who live potentially at the same address. And so that's kind of interesting. So let's go ahead and create some sort of a address ID, right? I hadn't thought about that from an access pattern, but we can go ahead and represent that. So I'm assuming in the customers table, that's not necessarily a full blown, here's what, or it could be potentially, but, and from our perspective, we might actually want to do that. It's, hey, we'll have a reference items that reference the customer's historical locations or addresses. And actually, that's what we have here. It's an address history table, right? It's not like give me all the customers with the same address in this particular representation, because that's what we're seeing is date address from, date address to, and customer address ID is actually a foreign key on customer ID, right? So that's not what we're looking at. And so maybe for our perspective, from our purpose, when I select the customer's record, And actually, I don't necessarily even need this attribute customer address, because what we're going to do is we're going to select the customer's data with the most current address item as well. How about that? And let's set up that data structure in a second here. But what do I want to put in here? Is there anything else I'd want to add? Looks like he's got commercial or domestic flag. We could put that in there, and then some other details. So we'll have commercial property and, some other details, right? And this would be the map that would be, okay, whatever blob data you're going to dump into this customer's metadata lives in some map here, right? And then just put some sample data here. So email jdoe and somewhere and virtual false. Yep. Okay. So there's our customer record. So then what we're going to do is add the address, and then what we're going to do is date range the addresses on the start date for the customer's address. And so it would, what we could just say here is that we're going to have, and what I probably want is these things to be located in a close proximity, because I'm going to be loading this customer partition with other records, right? The other records I'm going to load in here might be his phone number records, his call records, whatnot. So I'm going to partition this as customer metadata, really. So I'm going to prefix it as a hash, and then it'll be some timestamp. Let's go ahead and generate that in a second. But the type is going to be an address, and it's going to be the basically standard street. City. State. And then I think it was, what were these? From and to. And to. And so we're going to go ahead and turn this key into a, that's those of you who've seen the editor before know that we can assign these things called value templates. And so I'm going to just assign a value template to the address item for the sort key here. And it's going to be basically indicating the metadata leading key, which is A. So everything starts with A is going to be a customer's metadata item that we're going to want to see. And it's going to be a hash from date, right? Is really what we want to see here. Is that right? Yes. And let's go back to our value view, change from to date string. And what we can see now is if I select from the customer's partition where customer ID equals, X, starts with a limit 2, right? It doesn't really matter how many addresses I have here. I should get the most current address, right? As we start, and that's how it should work, right? Let's see if we add a new address with a new timestamp that's greater than that. And this will be an address. Again, the editor pre-populates the values based on the type. And so if I put this at from at a later date. Okay, so yeah, so I would need this to go down below. So my metadata value up here would actually have to be a hash. I think if I did this, does that work? Yes. And so I would scan forward index false limit 2. And that brings back the customer's metadata and his most current address item. Right? Yes. This date is later than that date. Yes. So as long as my from date, which is always going to be, my most current from date is always going to be my most current address, so to speak, then assuming that condition is true, and that should be true, when I move, I'm going to put the to date on the end of that time and the from date on the, which would be more current than the last from date. Then a query by customer ID equals X, scan forward index false, limit 2 brings back customer metadata and his address. And so I could do range queries for the customer by customer history. Where did he live at this time, right? Give me a customer ID equals X. sort key is greater than a hash timestamp limit 1, right? Brings back the customer's address on whatever date, or actually, is that right? That brings back his next address. So I would have to less than this time, right? Less than or equal to this time, not greater than this time. Greater than this time brings back the address he goes next, lives at next. Anyways, you get the idea. We can start to play with the sort conditions on the date range, do historical queries for where the customer lived during a given time, build the timeline for the customer, query, get the customer's metadata and his most recent address in a single round trip, so on and so forth. We're kind of slicing and dicing the data that seems to be built here when we look at, if I go back and let's take a quick look at the schema. That's kind of the relationship that's being built in the schema here. We have customers metadata, we have this address metadata, and that's history, right, for a given customer. There are addresses here, that are kind of, I guess you'd say, associated across customer addresses. We can go ahead and add those to the model. That starts to get us, all the customers that live at a given address type of situation. So let's go ahead and add those to the item. And that's where we would have some address IDs. And let's go ahead and how would we break those up? If we want to query, I guess we'd be querying on things like postcode and state and city, whatnot, And so let's say I would want all the customers in a given time range within a given location, that might be scoped by, like I said, those boundaries. Let's create a GSI on addresses. Let's see, GSI 1. Have a GSI 1 SK. And let's say that customer used to live in, and how do we want to break this up? These are physical addresses again, so they're going to have to be, so let's say let's go by state. Okay, so customer moved from, Texas to Washington. And then we would go by, now I guess this is the question. So, you'd have to decide what are your queries, right? I mean, because postal codes can go across cities. So are we querying by postal code? Or are we querying by, cities, province, county? Let's assume that this is going to be a postal code query. And GSI1 SK should then be a value template, which is, let's add postal code to the address. This is, I don't know, that's Round Rock, Texas. I know where that is. That's where I live. But I don't know any zip code in Seattle, so we'll just use some fictitious zip code there. And what I'm looking for in this sort key is a date range condition on finding everyone who had an address in this time, period or range. Again, these are arbitrary access patterns. We're just kind of coming up with these things on the fly. And so what I'm going to do is create another value template here for this GSI1 SK. And that is going to be postal hash. And I'm looking for people who were there. So it's going to be greater than or less than their to date. So it'll be, let's see. Postal, oops. Here's 2. Let's go take a look at the data and see what that actually looks like. Did I do that right? Yes, I did that right, I think. Yep. Okay, so we're going to need to stick some dates in here. This would be time. And this would be, And I'm going to have to put something in that's going to put it at the end of the sort range. So this would just be a holder, placeholder. And now if I said, let's create a GSI. Name GSI 1. Go ahead and create. Look at that. Yes, just catching questions right now, looking over at the chat. Yes, there will be recordings after this is done. It's up on Twitch and they stick around. Yeah, I know you got the question answered for you by one of the other users. Sorry, no moderators today. This is more of an ad hoc session, but that's okay. Most of these data modeling sessions are truly ad hoc, so that kind of fits the theme. All right, so let's take a look at that GSI now. And we are, so I have, okay, everybody in Texas in this area code between timestamp 1 and timestamp 2 are going to be people that, you know, had lived here at that time or at some point within that range. Is that right? Oh, I'd have to do, no, I need no, this doesn't work. This is an interesting query. I need people who, so they might not have left yet. So what I really need to do is query on their from date is less than or equal to today, right? Not their to date. So let's change that in our value map. I'm getting a little too wide for my data view here. Oops, stop that. There we go. And I want to change this to the from date, right? I need people who lived there and had a from date less than today and a to date greater than today. So there's going to be a filter condition on this query. And let's see, is that right? Yep. And oops, change our view and the to date and the from date. There we go. We're there. So let's go to the GSI. And we can see now, okay, I can query this and say everybody in Texas with a from date less than or equal to today and a to date that is greater than or equal to today. That gets me my query. That gets me my data set. Now, I guess my question here on this query would be, how much data are we going to hold on to, you know, from a historical perspective, right? Because all the people in your billing system that ever lived in Texas could be an awful lot, and so that could be a problem. I could say within a reasonable time from today, everyone who's lived here, you know, within last 12 or who moved here within the last 12 months would be a better query. Again, these are queries you have to start worrying about dimensions, right? I'm showing you how to, you know, slice the data, but we do need to worry about the velocity of data at this point, right? How much data are we talking about in that read? The filter condition could be, you know, filtering out a lot of rows, in which case, then maybe I'd go the other way, right? Give me, and that might be why I'd query 2. Give me everybody has a to date that's greater than or equal to today. Yeah, that would work. And that's actually better. I think my instinct was better the first time when you think about it from a data load perspective, right? If I say everybody has a to date greater than or equal today, I could never get anybody. My filter, my size could never be, or, you know, my to date greater than or equal to the time. Yeah, no, I guess it depends on how far back I'm querying, right? So this is one of these queries where you really need to know more about data load, data size, right? What are the dimensions of the query, the access pattern? Again, which side of the line am I querying and how far? Because, you know, I start thinking about cell phone billing or mobile phone billing. I start thinking about massive scale, large carriers. But, you know, that also could be, you know, overthinking the problem, right? Not all, you know, phone billing systems are run at massive scale. So, you know, this is one of these, but it shows you the idea here is there's dimensions of these queries that start to trigger other questions, right? How much data is being aggregated, right? And we'll get into that as well when we get into some of the questions from, you know, one of the people online who asked about, you know, location-based aggregations. All right, so that's probably a good discussion. Good enough of discussion around the customer metadata, the historical queries we might see on customer addresses. and whatnot. And again, these types of, you're hopefully thinking these types of historical queries, these are going to be more, not high frequency queries. So when you're cutting out, using filter conditions, that can also be a nice factor. If you're thinking about, oh, that's going to be an expensive query, hey, that's okay if you only run it, daily or, once a week or something like that, or even just, on an hourly basis, to scoop exceptions, right? These types of queries that can be grossly inefficient, who really cares, right? If all I'm doing is churning through this data once or twice, every now and then. But if you're doing it, with high frequency and high velocity, those queries can be really bad, right? So this is one of the things I think I talked about recently. The guidance in the documentation talks about when to use filters and scans, and some of the guidance they give, it's like, well, it's pretty prescriptive, right? But there is no prescriptive guidance when it comes to filters and scans, right? It's all about how much data are you trying to move, and how fast and how frequently, and what's the cost of maintaining a more efficient data structure, right? All right, so when should I worry about hot partitions? Okay, yeah, so the item size, yeah, there's some good discussion going on here on the chat channel. Thanks, folks, for stepping in and offering some suggestions and answers to questions. But bottom line is, if you start moving data faster than 1,000 WCUs on the write side or 3,000 RCUs on the read side, or some combination of the two, right? You got to understand that it's all IOPS, right? Read IOPS are actually cheaper than write IOPS, but bottom line is you get a combination of those two, which make up a collection of IOPS that the partition's capable of delivering. And if you start to exceed that, then you're going to start to see throttling on the partitions, right? So again, throttling might not be bad if you're churning through large chunks of data and you expect it and you're just going to retry and you're okay with that. If the table is built for maybe on-demand delivery at high throughput, you might have auto partitioning going across the table that's spreading that data out automatically behind the scenes. You can actually end up getting a lot higher throughput than that, I guess is what I'm saying. If it's a regular and repeated process, the data will end up getting partitioned across multiple, physical and logical storage partitions, even within, a single partition key. And so, it's interesting to watch the state of the system over time. And when you have these types of, high volume queries, how the system will try and account for that. For example, if I have, a partition of data that could be like 5 gigabytes of data, and I regularly run, scans at high, and try to push as much throughput as possible, the global access control and adaptive throughput system of DynamoDB will detect that, and it's going to start drawing partitions in the middle of those key spaces within those logical partitions and spreading that data out, and you'll end up getting 2,000, 3,000, 4,000 WCUs, but it takes time. And it takes a lot of regular, high velocity workloads, but you can force it to happen. But anyways, you should not design for that. You should design for 1,000 WCUs, 3,000 RCUs. If the system notices you're asking for more than that, it will try to accommodate you. That's what you should understand. But don't design for it. In any case, that's kind of the summary there of that discussion. All right, let's move on. Let's start adding some phone numbers to this. Is really what we're here talking about. And phone numbers are customer centric as well. So I'm just going to throw those into the customer's partition, and we'll probably prefix those with the phone indicating some sort of a phone metadata. And I'm thinking that for the general phone numbers, things here like the actual phone number itself, right? Whatever it might be, we could just don't even need them and just do, right? Maybe that wasn't a good idea. There we go. Okay, and if we want to add like country code at the beginning, we could certainly do that. Although I guess for this particular, might as well. So there's only going to be one. That's a unique key. So let's go ahead and say this is a phone number. It's called a phone. And what do we want in the phone? We want customer ID. We got that. That's the partition key. Number type code. Okay, so I was kind of like a little bit like, okay, what is this? But the number type code is kind of up here. It's kind of described in, I guess, it's kind of when you set your phone bill up, you say, is this my home, work, or mobile? It's okay. And so we can go ahead and add a num type. but that's really more of a kind of just a metadata attribute. And was that all we had here? Yeah, we had held from and held to, right? Because I guess you might have multiple users that hold the same number, and which indicates that, you know, that's kind of an access pattern right there, right? Who had this number at this time? So let's go ahead and say, let's add the number as an attribute, and we'll create the partition key, which could be a, where did the number go? There it is. This could be key dash. Okay. And that's fine. And then we can add that number. All right. And yeah, let's not worry about prefixing the country code and whatnot yet. And one of the things that was interesting was some of the access patterns around who called from this area, from this country, from this, you know, location and zip, you know, or area code. Certainly, those are the patterns that were suggested by somebody online. We'll go ahead and do that in a minute. But right now, we're just going to, we want these unique partition key values here on the phone numbers. That should generate a unique key. And what else do we want? We want held from, held to. Right, from date, to date, and details. From date. There we have to, yep. And details, I think we have. Yep. And we'll go ahead and generate some UUIDs here. Oop, not UUIDs. Date string. No, I don't need, and this is my current phone. And details would just be some map structure. And that's what we want. Okay, that's what we want. And so again, we wanted to say what was possibly, you know, who held the phone during what time. So let's go ahead and create that index, add those GSI attributes. And okay, so GSI1 PK here is going to be the phone number, right? Because that's really what we're querying on. So we want to create a couple of value templates on this. And that's going to be number. And this will be, so we're looking for who held the number, you know, at a given time. So it should be who has a from date that's less than now and a to date greater than now, or a to date that's greater than now, right? Really should be what it is. Who has the to date greater than now? Because only the current holder is going to have that, right? So, you know, well, that's not necessarily giving us, but it's again, it's the same type of query. It's basically saying, okay, what's the retention policy of the system? How many records should I expect to see for a given phone number? I shouldn't expect to see a high turnover, right? I should only expect to see actually a couple owners in the history of the number, right? So this is actually just fine. We can just say, okay, using our filter conditions on this query works just perfectly. We can say either side, if it's a from date greater than now or a to date, from date less than now or to date greater than now, or not now, but whatever your time range condition is. Let's see. So let's go ahead and say from, and back here. So now if I go back to the GSI, I should see, okay, if I query by phone number and I say this is the from date, so I want a from date that's less than now and has a to date that's greater than now, it should really return, no, not now. Again, I keep saying now. A from date greater than timestamp X and a to date greater than timestamp X, it should return only one item, right? You're not going to get, the filter condition is not going to filter out 100,000 items. It's going to filter out maybe one or two if that number had been owned by other people in the past, right? Or, potentially maybe a couple of dozen if it's one of these, temporary numbers that can just be handed off from device to device or whatever, but it's not going to be thousands. Okay. Even if it is, it's not going to be that expensive, and that'll be a very corner case, right? So I could see how maybe in some systems with a high degree of automation and, phone numbers are transient, they could be passed from device to device, that potentially you could generate hundreds, maybe thousands of records per item in the course of a couple of months or a couple of years. But even then, think about it, it's going to be small items. The read's not going to be that expensive, and it's going to be such a small corner case in any system that you're not going to have to worry about the velocity, I suppose, I guess is what I'm saying on the phone number query. All right. So what else do we have here? So we have, phone calls get made, right? And then there's some sort of calculation between, let's add the rest of the attributes we need. Did we get all the stuff on the phone number? Okay, yes, we did. Held from, held to, other details, got all that. All right, so phone calls get made on phone numbers. And so those phone calls have, timestamps again. So I would actually bucket those phone calls into the, let's call this a call, and we'll set up the partition key in a second. These do the attributes first. These would be, they're going to have the number, right, that was called. They're going to have the number that's associated to the call. You're going to have the number called type code. That was the, so that was, somebody had suggested this might be country code, whatnot, but it's actually not. This is, for the modeled in the UK, 0800, 0900 international, so those are kind of, if you're a US listener, that's 1-800 basically. 0900 is a billable call. So these are common type codes for call records in the UK. But we're going to go ahead and model these calls on the destinations and whatnot in a couple dimensions in a second. Okay, so I'm just trying to catch up on. I got to keep modeling here because I want to get through some of this stuff, and then I'll try and catch up on questions in the middle in a minute. Sorry, but let's take a look again. We're looking at the phone calls. So we have the phone call ID. I don't really need to worry about that. We've got the customer phone number. That's going to be in our sort key, but I do need that because I'm going to create a value template for those sort keys. We have a type code. So this is and we've got and type code would be used by whatever's chewing up the data, these records, and spitting out the bill detail lines, right? Because it's saying, hey, what type of call is this? What are the tariffs associated to it? Okay, here's a bill detail line associated with this call record. But we're going to get there in a second. We've got type code here is our last one. What else do we have? Sorry, I'm slowing down. Too many tables. I never thought I'd say that. There's never too many tables because there's only one. So what else do we have? We got the number called. Is that right? So number, we've got called. We've got start time. End time. Right? All right, other details. Again, these don't really need to call these out, we might as well. And so there we go. So now we're going to create our partition key template for the call type. That will be the number and the start time of the call, because any phone number can never be calling more than one number. I suppose, get it? Yeah, I guess you could have conference calls, but if we have a conference call, then I could segment at the end. I could say -1, -2. We're going to assume that for now we're not going to do that, but this is going to be on the number, and it's going to have the start time. Yep. Okay, so now let's go ahead and add some data in here. We want this number down here. You don't necessarily need to duplicate this in your actual data, but I need it for the value template to work. Oftentimes, when you look at some of the libraries like OneTable and DynamoDB Toolbox and some of these things, there's a tendency to kind of use the primary attributes of an item to generate the keys when you save it. So you don't have to actually pack and unpack these tuples. The libraries do it for you. I kind of like that. So that's why I kind of set this stuff up this way, because then when you export to OneTable, this tool actually allows that. It exports a OneTable configuration, then all those keys that I'm doing, those value templates, all that stuff, if you use OneTable, it'll just generate those values for you based on the configuration file that you can export from the schema, right? So let's say this was an 0900 call, billable, called, I don't know, all right, and started now, ended a minute or a second later, 4 seconds later, very fast call, and there you go. So this is a unique, this is always going to be unique, or if it's not, let's say I do a conference call, then I would say, unless we can go ahead and model that, let's add a conference call. I dialed somebody in, I added somebody to this call. This is also a call, and it would basically just say, okay, same number, billable, it called different number, and same start. We did a very fast conference call. What happened there? I think I did something. I got a bug. Did I? Yeah. Oh no, it resorted. That's what happened. Is that what happened? Yeah, it did a resort on me. What I need to do here is decorate the start with the -1, right? Since one of these guys came and see this is a collision on the sort key, right? And so one of these guys came in as a sample or as an add. So I would just decorate start with -1, and that tells me, okay, I actually had 2 participants on this call at this time, but one of them, this was a conference call. Essentially, I dialed somebody in. I said, hey, wait a second, dialed somebody else in. Okay, and then started the call. So that could be, a way to track, multiple participants on a call. Again, we always need to account for unique keys, or we're going to collide. So, and that could be definitely a function of the system that generates the call record, right? It's a conference call. You're adding somebody onto the call. So go ahead and, decorate that start time here with the -1. It's not going to impact any sorts, right? It's just going to, because that's just a decoration at the end of the string. So it still satisfies any sort conditions. If I call in here, I say, give me, who was on the call for this phone, what was the most current, recent call for this phone, whatnot, within a given sort key or timestamp range. Give me all the calls for this phone within a timestamp range. I will see all those participants, right? And that's more or less what the queries would be here, is what I'm assuming when we have the start date time, end date time, calls on the phone number. They're going to be ranged in give me all calls within a period of 30 days or whatever, 24 hours or something like that, right? So these types of key conditions work pretty well for that. All right, so let's assume that, okay, great. Things are working out pretty good here. We've got, records, historical addresses. We've got historical phone calls. We've got time ranged, records of participants on phone calls by number. So what are the other things we might want to index on? One of the dimensions that was, asked for in the call on Twitter, I think was, and I don't want to butcher this name, but I think it's Angre, asked for, how do we get all the calls from the Ukraine within a given range, date, time, or calls within a given country. And he was specifically looking for how do we set this up for a single GSI, right? So I can show you how to do that. There's a couple ways to do that. But again, this is one of these things where it's like, okay, what's the scope of this service, right? Are we trying to service everybody in the Ukraine, or are we trying to service an organization of, a couple hundred people or a couple thousand people, within the country of the Ukraine, right? So dimensions matter, right? Because the heat on these aggregations is really going to matter. So the first thing I'm going to do is kind of set it up and assume that, hey, what we're really looking for is, this is a whatever phone, IVR system or something for a small enterprise, maybe, okay, we're talking about 5,000, 10,000 people tops. Okay. We're not talking about the entire country of the Ukraine. Which, again, you can do it. You just have to understand what's the scale. And then next I'll comment on, okay, if we're going to do it for the whole country, what does that really mean? What we're going to obviously need here is a couple of GSI keys. So let's go ahead and add GSI 1, GSI 2. What did I do? GSI 1 SK, right? Okay, so we're still working with one index. And so, again, it's actually a nice demonstration of overloading. We've already got two patterns, multiple patterns on the GSI. This is going to be our third pattern. And, here we're going to say, okay, partition, again, I'm thinking that we're talking about maybe 5,000, 10,000 users, right? How many users are going to be on the phone at a given time? How many call records are really going to be coming in simultaneously? Probably not 1,000 per second or more, right? Maybe, a couple dozen per second peak, right? So, hey, that's great. We can go ahead and just create, partition keys on country ID, right? So, I guess what was Ukraine, the example was 380, right? So, US would be 01. These are US phone numbers, right? So let's go ahead with, 01 country code, and then area code might be another filter, right? Let's take a look. What were the other dimensions? Query by timestamp within a given domain. And also, what was it on the bottom? How to get all calls from Ukraine, all calls from all countries. Okay, so two different access patterns. And, this is actually where you're going to have to create multiple GSIs. I'm sorry. So there's no way to do this in one GSI at all. I can't do this with filter conditions. I can do this by the way I'm showing you now is by country, and then we'll show you how to get all calls from all countries. But I can't really do that. Could I? Yeah, I could do this in one GSI, right? Yeah, I just can't use country code as the GSI 1 PK. Again, got to think scale, right? If it's 5 to 10,000 users, then it's not a tremendous data load on the system. So we can start to think about, okay, that doesn't matter if I have low cardinality on my GSI, right? So you're looking for all calls from all countries within a given time range. Then really what I'm going to do is, again, think about it, 5, 10,000 users, how many calls per second, a couple dozen peak, great. I can create a single partition on my GSI. This is what you would normally consider to be a terrible access, design pattern, but it's not. Again, this is why I talk about prescriptive advice. There is no prescriptive advice. Sometimes low cardinalities on the GSI are just fine. What's the velocity of the data that I expect to be reading and writing? It's, very low peak, even across all partitions, again, as long as my user base is small. Now, if I were to say, okay, the entire country of the Ukraine, or an entire state of population within the United States, or the entire state of or country of the United States, then no, that's way too many people. It's way too many phones. It's way too many records, and the peak utilization of these systems is going to be well over 1,000 call records per second. So that's where we'd have to get things spread out, right? So again, our assumption is this is a system to manage an enterprise of 5 to 10,000 people, maybe even 100,000 people, right? But not millions. Okay, so in this case, I would say, okay, what I really want is a GSI for all phone calls. No problem. We're going to say, partition key is basically 0 of all phone records. It's going to have a sort key, which is going to be the start time. Is that right? So we're saying within a given time range, right? So with the start time between X and Y, or an end time between X and Y. Is that right? Do we want, so the question would be all ongoing calls. So I want calls that end within this given time range, and that's all I want. anything that has an end within this time range gives me a call that was active during that time range, right? No, anything that has an end or a start, right? Yes. So it's, that's actually a split query, I think. Is that right? You want anything that was active during a given time range. I guess that's the question. What do you want? Do you want calls that ended during this time range? I can do that in a single query. Do you want calls that started during this time range? We can, do that in a single query. Do you want active calls within a given time range? Well, I'm going to need to actually execute a split query and probably create multiple GSIs. Or, yes, that's the only way to do it. Or it's a start time less than the end range. Yeah. That's what we'd have to do. Start time less than the end range and filter on, we could do that. So yeah, this works. And so let's say GSI PK, GSI 1SK. And so this is going to be, we want start time less than end range. So this is going to be our start time on the call record. I'm sorry about having to think so much about this, but some of these record patterns are a little bit interesting because you got to think about the time range conditions and whatnot. But I think when we show the data structure, it should be clear what's happening here. This is also 0. And let's see what happens when we look at the GSI. So now the GSI, if I query the 0 partition with a range condition, and that range condition is saying that has a start time less than the end time of the, which is timestamp 2. So start time less than timestamp 2, and a end time greater than timestamp 1. Okay, that will give me the calls that were active during that time range. Now, again, depending on the historical data, that could be a really, really fat query, right? Because I'm basically getting all calls, that have a start time, and you could also you could range it, right? You could say, okay, I'm not expecting calls to last longer than X, right? So I mean, how much calls aren't going to last longer than what? I don't even know, long call, couple hours. Okay. So you could say, okay, and across 10,000 users, how many calls are you going to get within a couple hours? Even if they're active users on the phone quite a bit, that's not going to be, millions. It's going to be, potentially a couple thousand. So let's say it's a call center and, cold calling, customers as fast as you can and generating call records right and left. Okay. This is still going to be, a manageable number of calls if I bound it by, and if I know that's the case, then I would bound it tighter than an hour. I would bind it by like 10 minutes and say, okay, give me everything that has, a start time that's less than timestamp 2, greater than timestamp 1, where timestamp 1 is, maybe 60 minutes before my, range that I'm filtering on. Okay. And has an end time, right? An end time that's greater than timestamp 1 or timestamp 3, which is the start of my range, right? I kind of said that backwards. It should be timestamp 1, start of range, timestamp 2, end of range, timestamp 3, beginning of sort, or beginning of beginning of the sort key condition. So again, you have to kind of, I hope I'm being clear enough. Essentially, what we're trying to define is a boundary range that would include anything that I would expect to see that would end in my time range. And that gives me at least slices some chunk of data that is manageable, right? I mean, if I had, let's say, years worth of call history, and I said, give me everything that had a start time less than, the end of my range, well, that might be a pretty big amount of data, and then I'm going to filter it with saying, give me, and it also, by the way, has a start condition that's greater than the beginning of my range. That's great. It knocks out 99% of the data, but it could also be a huge chunk of data, a very expensive read. Right. But if I use that third condition, so to speak, where I say, hey, you know what, let's apply this sort condition that's, a fat enough range. It's got a start time less than or equal to now, or the, my end condition. And, it also has a start condition that's greater than or equal to, an hour before what I'm really looking for. Because again, you're not expecting calls to last longer than that, whatever, or even a day, right? Nobody's on the call for a day. It's not going to be millions. It's going to be potentially thousands at worst case, small items. Read's not going to be all that expensive. Those filter conditions work pretty good, right? I mean, they really do, as long as you can bound that sort key condition. And that's the important part here. So a couple of lessons in this example, right? This is, all calls across the enterprise. we don't have to worry too much about the velocity of the data on the GSI. So I don't care about this sort key, or the partition key. The partition key can be, a single value. It's 0, whatever. It can be calls. I mean, whatever you want to stick in there as a sort. As we want all the data to land in one partition. Oftentimes an anti-pattern. In this case, not so much, because we're not expecting the velocity, right? In the case where we start to expect velocity, well, what do? Well, we start to increase this number randomly, right? Every time a call record comes in, I'll assign it from 0 to what? I mean, how many call records am I generating per second? Okay, if it's the country of the Ukraine, that's a lot. Okay, so maybe it's 100,000. I don't know. No problem. Let's go ahead and create a range partition from 0 to 99. Every time we get a call record, we'll randomly assign a value between 0 and 99, right? Essentially what I'm doing is I'm changing this partition key to, random. Right. And, that essentially, spreads the data out, right, as the call records come in. So now if I go back to the sort key, I would see 100 partitions, right, 0 to 99. I wouldn't see just one partition. So this is a way to be able, again, for a small scale, managing an enterprise, right, 10,000, 50,000 users, this is no problem. We can just go ahead and, put in one partition 0 for country size scale. Let's add, whatever we need, let's estimate the call record flow. And there's plenty of systems that we have in place that can give us this type of data. And we'll say, okay, here's what I need to design for. And, we can actually watch the call record flow and say, when we start to exceed X, we can increase the partition key, right? And it's just a programmatic adjustment. So nice way to be able to spread that data out. And people start to kind of freak out when, but the data is all in different places then. Again, it's a distributed process when you're trying to look at data like this. So, it's a high volumes, of data. So spinning up a large number of processes is not going to, be all that terrible, right? So again, all countries or all customers, all calls, depending on the volume, one partition, many partitions. That start condition, make that condition reasonably selective on the sort key condition, and then use the filter to trim out, just a small number of items instead of a large number of items. So that's an interesting technique, right, to make sure that you're not over reading, so to speak. Those fat reads can kill you, so we don't want to see many of those. All right, so let's talk about now. That's all country or all calls across the business. Then the other question was, okay, all calls from Ukraine. And so again, two ways to do this. The first way is, okay, if I need to filter out all the calls from a given area code, all the calls from a different given country code, again, add those attributes to the item. And if it's a small number of calls that are aggregated into a single partition, then the read's not hurting me to get all the calls within a given time range, right? And at that point, I can add filter conditions. And okay, it's a fat read. I mean, it might be, the calls, I retrieve, a couple thousand call records, and I filter out 900 of them, but in the end, it's what is it, 10, 20 RCUs. Again, how often are you making that read? If it's a high velocity read, that might be too much, right? But if it's a low velocity read, then which usually those types of filtered queries are, it's like, hey, get me this because I need to see X, and the kind of human driven interactions, right? Searches like that. Although there are, of course, regular like monitoring systems that look at, get me the data last 60 minutes, 60 seconds, whatever, and make decisions. But generally speaking, even those workloads you can categorize as not high velocity. Those types of fat reads are just fine, right? It's okay to filter things a little bit. So I would say that this is how you do it with one index, right? In case of a low velocity system, let's go back here and change our sort key, back to, just 0 partition. We can see on that low velocity system, how, one partition, all my data, how many people, how many call records, not going to be that many, couple hundred, couple thousand, filtered by country, by area code, by zip code, by whatever you want to filter, it's not terrible, right? Give me everybody in the company that called this number, right? We've got a number called, I can use that as a filter condition. Again, these are very valid access patterns, especially for low velocity queries that run infrequently on the data that that are and especially user driven operations, right? UI driven operations. They're not high frequency, especially in these types of systems, right? I mean, how often does the call center operator sit down there and start drilling through the data like this, right? Not very often, right? Usually when there's problems or issues, or most of the stuff is kind of automated processes. That is the one thing we didn't get a chance to add yet, is the build detail lines. And I mean, I've got a little extra time here, so we can go ahead and throw that in. Let's add that right now. So if we look at the model that we've had, I'll go ahead and pull that in here. You can look at it. Again, customers, customer addresses, cell phone numbers. We've got cell phone calls. We showed you how to index those call records on country ID, whatnot. If I were to go ahead and again track entire Ukraine, I would add a GSI2. I would start partitioning those calls by country ID and whatnot, and spreading it out across multiple partitions instead of using filter conditions. Even on a right sharded partition set, I'd probably would prefer to go ahead and create country specific or access pattern specific indexes, because when you're talking about millions and millions and millions of records, then those filter conditions can really hurt, right? They can create hot partitions really fast, and we don't want to see that happen. So anyways, let's talk about build detail lines. This is called out here in the data model as what do you call it? And that's exactly what they are. They're kind of annotated, items that show up on your bill based on the type of call it is, right? Is it a 0800 call? Is it a 0900 call? In the UK, they're billable by minute, toll free. Then, of course, international, billing international, various tariffs and whatnot. This is kind of interesting because when you think about this system, right? How would I run this system? Well, first thing I want to know is, what do those tariffs look like, right? I mean, is that a large collection? Is that a small collection? I imagine it's a relatively small collection. So I would say, let's create just a small, list of tariffs that would just get loaded by the, as a configuration item, for example, when the Lambda function initializes, so that it doesn't have to make lookups all the time as it kind of creates these build detail lines. And that's really the question here, is how much work, right, is in creating these build detail lines? Is it kind of like, hey, really fast insert an item, or is it, oh, look up from this, oh, go get that, oh, I got to get the current rate for this, or whatever. I mean, these types of, you got to make some decisions here about how these build detail lines are kind of created. The model here kind of calls that out. Calculations are done between the customer phone calls and build detail lines, and so that's really what we're trying to do, is figure out, okay, what are the annotations, so to speak, to the customer phone calls, and how do we want to store that data, right? Do we want to store the build detail lines as annotations within the other details of the phone calls? And that really depends on the types of access patterns in the system, right? Do I want to get all the tariffs for calls within a given time range, and whatnot? That would really dictate that how we would want to model that data. So let's go ahead and look at that from the perspective of exactly that. We kind of want to model those build detail lines as independent data items, right? So in this particular case, I'm assuming that when I make the query for give me all the call records for a given time range for a given number within these within my partitions, that I also want the associated build details for those calls, right? And so we're going to want to build a key structure that's going to line up well with our date ranged items here. And so let's go ahead and call this out as a detail. We want to add what do we got for build details? Bill header ID, and so this is we'll be aggregating build detail lines up under bill header IDs and shipping those out to the customer. So this is absolutely something we want to make. We want is the header ID, because that's going to be a GSI. We're going to aggregate all these bill details under, right? So give me all the bill details for the month for this given bill so that's going to be another partition that we're actually going to define on this table, is a bill header item that's going to have all the top level summary, whatever, from date to date, for the bill summary. We've got what do we got? We got phone call ID. So this is going to be basically the sort key is going to be what we're going to create here for the annotation there. And we're going to want, I guess we're going to want a line item ID, right? Some sort of detail ID, because that's what's going to generate uniqueness. When we generate these things, they're going to have a key. So again, we want a key structure that's similar to this, right? So let's go ahead and copy that formula. Where is that? That's, what do we say? We want this, right? So let's say I have that. And where are we now? We're up here. Okay, so, and this means we're going to have to carry the same, since we want to show up in the same line and we already have the call details, we're going to kind of denormalize the call details across the build detail, the detail item, because I want them to show, and we don't have to do this, but I want them to show up in intermixed within the calls to show the billing details for each call, right? So that means that we're going to need, what do we need? We need a start time and end time. And what else might we need that's denormalized? In here, they just want a tariff ID, call duration, and call cost. Let's add those first. Let's see, detail ID. You want duration, cost. You want the start time. Number. So we're denormalizing a bit so that we can get what happened here. So it's sorted out, okay? And so this number is going to be this number. And probably, yep. Where do we go? We're there. And then start time is going to be this start time. And this is going to be a detail record. So the start time, since we can't, again, collision on sort key, right? So this is a table. We got to be concerned with collisions on the sort key. If we're, we want these details intermixed with our calls, but we also want, we have to have unique sort keys. So let's decorate this start time with a detail identifier, right? -D. So this is the detail for the call. And, this one might not generate a detail because it's a -1, right? So again, whatever the billing detail system is, we'll do that reconciling, right? If we say, okay, hey, we want, I'm going to process this item and this item, and then instead of, if this item, the detail item doesn't exist, I'll create it. You can actually, in DynamoDB, updates are all upserts. So if the item doesn't exist, it'll create it. So you can just go ahead and fire your update process and, update all those attributes in the billing detail item as you process this record or this record. It doesn't really matter if you process them in order or not. Again, remember, DynamoDB streams processing is process order of items, as they're received, order of updates as they're received by item, but not across items, not guaranteed. So, but that's okay, because all we're really doing for each one of these things is updating and upserting a detail record. If it exists, we'll update the cost attributes or whatnot. If it doesn't exist, it'll create the item, right? So to structure the query accordingly. What was it we wanted to look at? So build detail lines by tariff, right? That was one of the things that we thought, hey, give me all the build details or all the calls that were that were subject to this tariff and this time range, right? So, okay, there we go. So let's say, and we've already got a start time. We're going to actually need the end time here, I think, for this query. So let's go ahead and add that. And that's going to be this time. And we're going to want to add some keys to this item. So that's going to be GSI1, PK. And GSI1, SK. And what do we want for this? So we're saying all calls by tariff ID. So GSI1 PK is going to be the tariff ID. So we'll go ahead and I don't need to add an attribute for that. We'll just say GSI1 PK is tariff ID, tariff 1. GSI1 sort key would be our end date, right? So let's create the, where are we now? Detail GSI1 SK. This would be end. And let's go back. We will look at that. And if I look at GSI1 now, what happens? GSI1 is like way overloaded. Check that out. We got like all kinds of access patterns here. Calls by state and time range and zip. We've got the calls by number across, what was that? I don't remember. I have to watch my own video. Calls across all customers in the enterprise. We've got the calls by tariff ID and timestamp and time range. Again, this would be one of these ones where I use I need my start and end boundaries. So I would say, okay, let's query where the end is less than or equal to my TS2, where the start is greater than or equal to TS3, and filter on, start equals TS1. Right. This is kind of the 3 condition query we talked about, right? We want the sort key condition, the start range on the sort key condition to be a little bit before the actual calls, and I'm looking for, because I want to capture all those calls that started before and ended after that, start of that condition, right? So that's what I'm assuming is we're looking for, and that's the key to making that query efficient. Because if you don't do that, then you're getting all of history, right? If I only have the one start condition or the one condition on my sort key, which is the end condition, end timestamp, then I get all of history, and I filter on the start timestamp. I filter out, all prehistory, and I still lose everything that, started before that timestamp. So again, you got to kind of add that as some sort of condition anyways. So, all right, we are past the hour. That's okay. We usually have an hour and a half for the show. That's, but, scheduled, but so I can go through any questions here. We can talk a little bit about, if anyone has any questions that did not get answered. Let's see. So I have to do the work to shard items on the table with this technique. Yeah, that's the thing. If you don't want to, if you have a velocity of data that's, a high velocity, then you're going to need to run it as a distributed process, right? It's that's just kind of how things, go in large distributed systems. Honestly, the DynamoDB, I wish we had more throughput per partition. It's a little bit on the light side, but honestly, it's not a terrible thing. When you start coding it, you realize, hey, I just spin up a bunch of runnable tasks that consume this data in chunks. And it's funny because you talk to customers who operate at scale, and they all take this army of ants approach, right? It's not like, we're going to build one monolithic process that's going to ingest and do everything for us, right? It's always got to be a distributed system. We're scanning the data across chunks and spaces and processing it in parallel. And so the sharding actually feeds right into that, right? It's like you give, hey, this processor can process records at X, give it, shard 0. This gets shard 1. This gets shard 2. So on and so forth, right? It's just a nice way to be able to, kind of chunk the data across, multiple containers, so to speak. Okay. All right. Let's see. Anything else? Yeah, videos are going to be up on replay. Phone numbers, customers in Seattle. Again, that's what we were talking about. It's like, okay, do you want a date range on that? Or are you trying to say, oh, give me everybody who has a phone number in Seattle right now? I don't know if we set that up. I don't know if I have enough time to set that up, but let me see if we did set that up. So I've got, give me everything in a given area code right now. Yeah, so this would work on GSI1. If you want everybody that has a current phone number in Seattle, you would have to, right now it's set up to query by zip code. So that would be part of the issue here is zip codes can be, cities can have multiple zip codes, and the city can, zip codes can span multiple cities. So it's not the most efficient structure to get everybody in Seattle, but you could get everybody within a given zip code that covers Seattle or parts of Seattle with a starts with query. You could say that's everything that this is. What did we use for that key? We used, I believe that was the, what was that? That was the phone number, and it was GSI1. So it's the from date. Okay, so we're looking for everybody who has a phone number that is, let me see. how does that query work if we want, oops. If we want to get everybody who has a phone in Seattle, I would have to say everybody has a from date that's less than now. And that would not be a good query. Again, it depends on the history, the number of users. For this is if this is a enterprise of 5,000-10,000 users, then it's not really a painful query, but it's not the most optimal way to do it. The way I would want to do this is I would want to have everybody that has a to date that is let me see, greater than or equal to now, because the to date item, is that right? To date, what happens on the current number, the to date is, A, or yeah, that's really what I'd say is, okay, I need to say everybody who has a to date equal to A, or, it has a zip code hash A, right? Whatever, 99999 hash A. But I'd have to have a separate index because this one will give it to me again with, I'd use a filter condition, but it's not the most efficient way to query. If there's 5,000 or 10,000 users in the system, that's not a problem. If there's millions of users, it's a hideous problem. So, again, take into account when you define your indexes and how frequent is the access pattern. Don't worry so much about something that's going to be, an ugly access pattern if it's an infrequent pattern. Okay, this is something that people always make a mistake on. I see it all the time. They create an index that creates a beautiful access pattern for the read side, and it's maintained at high cost, right? I mean, it's like, okay, I run at high velocity. I have thousands of writes per second that I'm hitting that index on, and I'm maintaining this beautiful data structure to be able to query it. But hey, in the end, I query it once a day, once a week, once a month, maybe, and all I need to do is find the exception conditions. Well, scan the table, just spin up the read capacity on the table to a couple million RCUs and scan that table. Even if it's a huge table, what's that going to cost you? Maybe a couple $100, $1,000 to scan that table every day. Well, what's it going to cost you to maintain that index at 100,000 WCUs with a terabyte of data on it, right? Even if you go keys only, okay, let's say you do keys only and it's a couple hundred gigabytes of data, well, a tremendous amount more than $1,000 a day, right? So again, think about scale, and honestly, at scale for most applications, what's going to cost you to table scan your data with a couple thousand RCUs, maybe 10 cents, $1. Right? What's it going to cost you to maintain an index at even 1,000 WCUs? A couple $100 a day, right? You don't want to do that, right? So think about those access patterns and the shape of those patterns, the velocity of the patterns. That's what drives the cost, the decisions you're making in your data model. It's okay to have inefficient data structures when you're doing it for a reason and you understand why. And again, why am I using only one partition here? Well, because I don't expect to ever see thousands of updates per second on the GSI. It's okay to use a low cardinality set. Oh, well, I do. Let's expand that out. Always the access pattern informs, the design decisions. All right, so we're well past the hour now. Real quick, if there's any other questions that came up. Yeah, I appreciate that. I really do appreciate you guys and the response to the content. I'm going to keep it coming. We've got a couple of really great sessions coming up here. I'm going to be doing a session with Eric Johnson. We're going to be talking about single table design for AppSync and Amplify. It's kind of a mystery box for a lot of folks, but it's really not that hard. And we're going to go through how to create and iterate across those result sets and populate a GraphQL object, a response object that maps to the schema that's defined in your Amplify API, right? So and it's easy enough to do, right? Just all you have to do is add a little bit of code instead of just going with the default resolvers, and all of this stuff works. And a lot of customers that do it actually experience a lot of efficiency because they don't have to do a lot of teardowns on their tables. They can just drop and recreate indexes and whatnot, and it's a lot faster. It creates the API that's much more performant, and we'll demonstrate why. Jeremy Daly's going to be on the show in a couple of weeks. We're going to talk about what he's up to and his new serverless framework project that he's working on. So we're going to have a lot of sessions coming down the pipe here. It's going to be really interesting. We're going to do another focus session on Athena and exporting to S3 and Audit Trail audit log workflows, which is also going to be an exciting topic. So thanks so much for making this a really popular show, and let me know if you have any other ideas for what you want to see. I did get a couple on those tweets for many to many, general ledger accounting system. Those are definitely things I'll throw into the future sessions, and we'll get that stuff out there. But thanks everybody for your time, and that's what we've got for you today. Talk to you later.